Okay, we are just going to be looking at these lovely notes and just kind of going through. You can follow along for our rotations. Let me go ahead and present this. So we're going to talk about those rigid transformations. Remember, rigid is the pre-image and the image are geometrically congruent after the transformation occurs. So you're looking at essentially the exact same shape. Sorry, let's get to the right screen here. Okay, so there are a couple things. So rotation sometimes is a little bit more difficult, probably because there's a few more formulas. And I think one of the things that if we keep just some general understanding straight, you can kind of figure out how to get those formulas. So a couple things. When we rotate something, we are moving it about the origin. So let me get, and you can also rotate any object around a different point, but for right now, we're just going to start with points around the origin. Couple things to look at. When we turn something, if they give you a direction, they say, you know, this may degrees clockwise or counterclockwise. We have to be aware of where that direction is. So clockwise is just like a clock. It's like turning to the right. If we're looking at the quadrants, it's going this way, right, around here. So 1 to 4 to 3 to 2. If we're looking at counterclockwise, that's how our coordinate plane is labeled. We start at 1 and we go counterclockwise to 2 to 3 to 4. So, you know, if I say 90 degrees counterclockwise, if I'm starting in quadrant 1, 90 degrees is one quadrant. So I'm in quadrant 2. If I'm starting from quadrant 1 and I say 90 degrees clockwise, I go to 1 to 4. Right? So that's just kind of thinking about the direction. In geometry, there might be times where they don't specifically say counterclockwise or clockwise. If they just said turn an object rotates 90 degrees about the origin, and they didn't tell you which way, we always assume that positive angles are going to be counterclockwise and negative angles are clockwise. Okay? So these are my positive angles. And these are my negative angles. I know that in pre-calculus, they don't tell you the direction, and we just use positive and negative angles. Geometry, I've seen both, so just to be aware. Let's talk about, again, counterclockwise is kind of the normal standard. So if you think about like a protractor, the 0 starts right here. This is 0 degrees. This would be 90 degrees. This would be 180 because 2 times 90. And then this would be 270 degrees. And all the way around full circle is 360. If I'm going the opposite way, if I'm doing clockwise, so they might say 90 degrees clockwise, I'm just abbreviating here, or they might say negative 90 degrees. Right? If I went on 180 degrees clockwise, I'm still going to end up in the same spot. So you're probably just going to see 180 degrees and it doesn't matter. If I were to do 90 degrees counterclockwise, that's the same as 270 degrees clockwise, which is negative 270. Okay, so just being aware that that's kind of the directions. And then the other thing I want us to be aware of is just a review real quickly of the signs in the quadrants of our X and Y coordinates. So thinking back, every ordered pair X coordinate is positive and every Y coordinate is positive in quadrant 1. And then when we go to quadrant 2, our X's are negative and all of our Y coordinates are positive. And then in quadrant 3, everything's negative. And in quadrant 4, my X's are positive and my Y's are negative. All right, so let's talk about just how we can do some transformations. And there's multiple ways. We are going to get some rules, but if you don't remember the rules, I like for you to have a backup method. And if you don't have that rule sheet in front of you. So here's my quadrilateral, ED or DEGF or FG, whatever. And if we're going to go 90 degrees counterclockwise around the origin. So one of the things that you can do, and I just want to show something. Notice I'm just going to highlight my x-axis here in green, and I'm going to highlight my y-axis here in pink. For right now. If I rotate this 90 degrees, so that means, you know, here's this, you might have seen something where you upload an image and you want it to look like this, but it comes like in on your screen like that, right? We have to rotate it. And then that was a little bit more than 90, and then it'll be the correct way. Well, that's kind of what we're doing here. We're going to take this shape and we're going to rotate it down here. Now, one of the things we can do, we have our points, D, E, F, G. You can look and see, all right, let's just spin our graph 90 degrees counterclockwise. Well, counterclockwise is this way. So we're going to go 90 degrees counterclockwise. I'm abbreviating CCW. And I would turn it and it would look like that. So it looks like if I now look at my thing and ignore where everything was, let's just say this is a new picture, except this is the image now. Notice here's my new quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4 on this new image. Also notice that now, before, remember our X was green, now my Y-axis has become my X-axis, and my X-axis has become the Y-axis. Turn back. So it looks like my X's and Y's are going to probably switch maybe a little bit. And you can, maybe not on this one, but if you were just had a blank graph, you could actually just turn your paper, now plot your points of the original ones, and they would be, so if I just said, okay, -8, and here's my 1, 0, and so I go through and find this, I can go ahead and plot some of these. Well, I know here that this was -8, 0. It's on my x-axis. And so when I bring it down to quadrant 3, that's going to become this axis right here. So it's going to be -8, 0. But really, that is, when I turn it back, and now when we look at this next one, G needs to be right here. And I'm looking at, this is -5. So -5, there's my G prime, there's my D prime. And just notice that DG was 3 units and the image is still 3 units. We are geometrically congruent. Just try and sharpen that up a little bit. And so this is going to be 0, -5. All right, as we do the rest of these points, we can go through and see. I believe this is right. Let's see, 1, 2, 3, 4, 5, 6 units long, and this is 1, 2, 3, 4, 5, 6 units long. So I'm still isometric. I'm still rigid in this transformation. Everything is geometrically congruent. Well, let's compare our new coordinates here. So F now is at -6 and -8. And E, oh, we already had, oh, that was E, -6, -8. This one is, F is -6 and -5. All right. Excuse me. So when we are looking at our pre-image, it started in quadrant 2. If I'm going 90 degrees, it's going to move 1 quadrant. So 90 degrees is going to move me to quadrant 3 if I go counterclockwise. If I'd gone clockwise, I would have been here in quadrant 1. Notice everything looks the way that it was. It's supposed to look like this. That's what our image should look like, and sure enough, it does. Okay. So if we're looking at just the values, I noticed D, they just seem to switch places. Now E switches places, but the signs are a little bit off. So it's not like you just switched them. So I'm going to say X and Y. It seems like they switch places. Right? But some of the signs are off. Right, so this sign didn't switch, it became the opposite. The 0 is kind of hard to tell because 0 doesn't have a positive or a negative sign, so we can't really tell there. But it looks like just the X coordinates were affected. Our Y coordinates here, they didn't change. So what I do want to say, when we notice the signs of the X and the Y values, I should say compared to the quadrant they're in. And what I do want you to notice is that all of my signs of this image match the signs of the quadrant that they fell into. Because look, this is all, everything should be negative. So save 0, everything's negative. So the signs of the image match the signs of the quadrant they are in. So in this case, all negative. Okay, so sorry, there we go. You can check I do have the notes, the PDF, if you're just looking at that. On the back, so before we get to these rules, I want to just talk about this. If we think about, look at my little piece. Remember here was my x-axis. Here was my y-axis. And let's think about what happens to these axes as we switch. So if I go 90 degrees and I do counterclockwise, my y becomes my x now, and my x becomes my y. The x and y switch places. If I go 180 degrees, so let's start back. Here's this. So that's one turn, and we need to go. There's 1, there's 2. Oh, we're back to exactly x and y are in the exact same as they were. What happens if I go 3? Okay, one turn, they switch. They switch back. On the third turn, they switch. So every 90 degrees, your X and Y switch. So your X and Y ordered pair. So if we're watching this one, okay, then they switch places, then they switch back, then they switch places, then they switch back. So if I did 360 degrees, that's 4 quadrants. That's 1 switch, 2 switch, 3 switch, 4 switch. Oh, back. Well, that makes sense. 360 degrees, you'd be in the exact same spot. So that's where I say, there are some rules, but every time we go 90 degrees, the signs are going to switch, the X and Y are going to switch, and then the signs are going to take the quadrant that they're in. So let's create these rules. So 90 degrees counterclockwise. Sometimes you might just see it like that, positive 90. All right, so we've switched counterclockwise. Our X and Y are going to switch places. Now, the sign sometimes throws people off. Let's say we're starting in quadrant 1 because everything here is just positive. If I start in quadrant 1, right, everything's positive. In quadrant 2, it's negative and then a positive, and then negative, negative, and positive, negative. Okay, so if I start in quadrant 1 and I go counterclockwise, I'd end up in quadrant 2. That means whatever's here needs to be negative. Okay. 180 degrees, well, that's just going to be 180, right? So positive 180 for counterclockwise. And if I'm looking at that, if I start in quadrant 1, okay, my X and Y switch once, then they go back, so it's still going to be X and Y, right? They flip back. But if I started in 1, I'd end up in 3, and so they'd be the opposite signs. Let's see if that would work. If I started in 4, okay, the X would be positive, the Y would be negative. I'd end up in quadrant 2, because that's 2 quadrants away, the opposite of positive is negative. The opposite of negative is positive. So it does work wherever quadrant. I just say when we're creating our rules, it's probably easiest to start in quadrant 1, thinking about that. All right, so you might see this as a positive 270 degrees, or you might see it as a negative 90. They are the same. So if they say to go 270 degrees counterclockwise, I'm starting in quadrant 1, I can count 3 quadrants, 1, 2, 3. So I'd end up in quadrant 4. Or I could just, instead of doing that, I could just go backwards the opposite way and end up in this quadrant 4 as well. So let's just say, are we going to be flipping them or not? So they flip once, they flip back, they flip again. So we do flip them. And in quadrant 4, this one should be positive, and whatever the second one needs to be negative. Okay, so these are my rules. And let's go ahead and then look at some of these examples. So if we're looking at, we're going to graph this image, write the coordinates. I'm comfortable with whatever way you should be able to do these kind of both ways. So we'll do a couple of them. Let's do a couple where we just graph them in case you're given a graph so you can figure out how to do this. If I'm looking at B and C per se, so we are going 270 degrees counterclockwise. Got to pay attention to which direction and how many. So 270 degrees counterclockwise. So there's 1 all the way this way around. So we're going to go, here's 1, it's 90 degrees, 180 degrees, and that's 270. So I'm going to end up in quadrant 1 for B. And if I think about where that's going to be, let's just take a look and see what it's going to look like. So I'm going to go, here's 90, there's 180, there's 70. So look, that's what it's going to look like. It's going to be kind of a different orientation. B and C are going to be vertical, right beside the y-axis. That's what it will look like. So it's 9 units away, and now it's going to be 9 units and 1 up here. Okay. I personally have a harder time seeing this visually. I do like to write an ordered pair down, and I like to think about the rule. So what happens when we use this? Remember, it's going to go to y and then the opposite of whatever your x coordinate is. So here's my y, that's got to come first, and here's a -9, but the opposite of that would be +9. And sure enough, did our point go 1, 9? Yeah, we're good. So if we look at this, here's my rule. Think about, they're going to flip, the x and y flip, and in quadrant 1, everything's positive, so I could just think of it that way, right? 1, 4. D, D might be a little tricky. I'm still going to count this as quadrant 1. Doesn't matter, it's still moving over here to quadrant 1. So it's going to go over here, and it's going to be, they're going to flip, and everything's going to be positive. And E, when we look at that, E would bring it all the way over here. They're going to flip X and Y, and everything in quadrant 1 is positive. All right, so now let's plot our points, and you can go ahead and do that. And then check your PDF. I think this one, C, ends up being right there. Let's see, 4, 0, 1, 2, 3, 4. D prime, and then 4, 5. 1, 2, 3, 4, 5. And I might have to use a straight edge here, so my lines don't look too wonky. Okay. All right, and you should, if you've done it right, it should be geometrically congruent. I know that's one of your big clues to see if you've kind of done the correct transformation. All right, again, let's look at, write the coordinates of the vertices after 90 degrees clockwise. All right, let's think about what that rule is. 90 degrees, I know every time we move 90 degrees, my y and my x, they're going to switch places. So I know it's going to be that, but I'm not sure on the signs. So let's think about if we started in quadrant 1 and 90 degrees clockwise would put me in quadrant 4. where my signs need to be at. So that's going to be my rule. And so when we look at this, notice it's the exact same rule as our 270 degrees counterclockwise, because they are the same, essentially, transformation. So again, let's look. We're going to swap these and take the opposite of the x coordinate. So all of these are going to be the opposite signs. So 0, positive 3, and then 8 is my y, and 0 can't really have an opposite. And then this 8 is my y, so it's got to come first, and then we have to take the opposite. And those are your ordered pairs. Okay, so I encourage you to try the practice that we have that's been posted to Google Classroom. So hopefully that's helpful. And let's